Okay, now in part B, we are asked how long is this projectile in flight for the whole flight. Okay, so how long is and basically what we're trying to eventually figure out is how far did the projectile go. And the first step to do that is to figure out how long is it in the air. Okay, and then we can calculate how far it actually went. Okay, so let's go ahead and erase this stuff here. Okay, so part B then, we need to figure out how long is that projectile in the air. Okay, and I erased our x and y velocities initial. This was 24.57, and the y initial was 17.21 meters per second. Okay, we don't want to forget those. Now, in part B, we want to know how long is it in the air. Well, perhaps I think the simplest way to solve this is to remember if you throw something straight up with 17.21 meters per second velocity, when it comes back down and hits the ground, it's going to be traveling downward at the same speed, but it's going to be a negative velocity, negative 17.21. Okay, and we can do that for this problem, even though we're not throwing it straight up. You can basically treat it like you threw it straight up, because you can completely separate y motion from x motion. So our final velocity then, our final y velocity at least, when that projectile hits the ground, it's going to be negative 17.21 meters per second. Okay? So if we want to know how long is it in the air, well, all we have to do is use our simple equation that relates velocity and acceleration. So Vy final equals Vy initial minus gt. Okay? So that's our expression for the y velocity in terms of acceleration. So we plug this stuff in. Negative 17.21 is the final y velocity. 17.21 is the initial y velocity. Minus g, which is 9.8, times time. We subtract this from both sides, and then divide both sides by negative 9.8, and we get a time of 3.51 seconds. So that's how long the projectile is in the air for that full flight. Okay, now we're asked in part C, we're asked to calculate how far does the projectile go. And remember, since we've completely separated x and y motion here, well, the x velocity is 24.57. And remember, the x velocity won't change for the entire flight. Okay? So our constant, we have constant velocity in the x direction. Okay? That the g acceleration is entirely in the y direction. So we can use our constant velocity equation that we just developed earlier, and that says our final position is equal to the initial position plus the x velocity, or the initial x velocity, since it doesn't change, times the time it's in the air. Okay? So if we subtract x initial from both sides, okay, we subtract that from both sides, the equation then becomes this. It becomes x final minus x initial is velocity times time. And so x final is our position out here. Okay? X initial is our position there. And so that's how far a projectile goes. And this is typically called the projectile range, or R. And we'll develop a formula that works in calculating the range in the lecture here in a little bit. So this is our range, and it's velocity times time, x velocity times time. Now our x velocity again is 24.57 meters per second. The time it's in the air we calculated in part B, so that's 3.51 seconds. And that gives us a range for this, or a distance, a total distance this object flies, that's 86.2 meters. So there's our solution. We calculated how far this projectile goes. And so the formula in calculating how far something goes then is first you need to figure out how long it's in the air for the total flight. Okay? And then you can use your x motion equation here to calculate the total distance. Okay? So we needed the time because that comes into this equation here.